Hello. My sound is clear, beta? So, very good morning to all of you. Due to connectivity issue in my laptop, the lecture is delayed. But we will try to complete this taking the extra class in afternoon. Okay. So this one lesson system for built-up column we have started built-up column design and steps in design of the lesson system we are seeing in the previous class. And on Thursday, due to the connection issue, we are not able to take the lecture, but we will complete, inshallah, by arranging extra class in afternoon, so that this lesson column, lesson system should be finished. Okay. So next column is the if there is heavy load or load which it is not able to taken by the single member road distance section, then we are joining the different road distance sections, and that was already covered to increase the load carrying capacity of the compression member. Releasings are because mostly our failure are due to the buckling of the column in compression, and the buckling of the column, it may be uh, buckling of the column as per the end condition is different. So this is the buckling. Okay. So generally, if single road is still section, if you see, if you I section, so there it is depend on the radius of gyration of the system column. And radius of gyration of column is depend on the moment of inertia of the system. Okay, so to increase the moment of inertia, because we know that the R minimum radius of gyration is nothing but under root of I upon A. I upon A. I is the radius of this moment of inertia. I is the moment of inertia, and A is the area, because area is fixed. But at two direction, if you see, this is the ZZ axis, major axis what we are seeing, and this one is the YY axis. We are saying the minor axis. So mostly the YY axis, minor axis having very less radius of gyration in single angle section. What we are doing, we are placing the two I section or two channel section back to back or facing each other, such that to increase the radius of gyration. Such that to increase the radius of gyration, and if you increase the radius of gyration, so what happens? The radius of gyration, if you increase in both direction, or if you make the radius of gyration in both directions same, it means that your I ZZ is equal to IYY. It means that your IZZ equal to IYY. Okay, so that's why if you do that, what happen? You automatically, because area cross section area is same, your radius of gyration in both direction will be same. So what happen if you are choosing the single action angle section, sorry, single section, single roll distance section? What happens about one axis? Mostly about the minor axis, y axis, the moment of inertia is very less, and that's why what at minor axis our section are weaker. To strengthen the section by doing such that IZZ is equal to IYY, it means that RZZ is equal to RYY. The slenderness ratio from both sides in both direction or both axis will be same, so that the stability of the member increases and the load carrying capacity increases. It will not fail in buckling about the minor axis. Okay, so that's what we are doing. by doing a member apart at a distance, because these two members we are making a distance. This is spacing s. Okay, so we are making a part, and we are joining it with the inclined bars. That is the lattice. It is called as lacings. Okay, such that they will act a single unit. Okay, so if you make a part, what happens? Your radius of gyration is we are doing we are making such a part that our radius of gyration about the y-axis and z-axis will be same. It means that about slenderness of about those axes will be same, and when we are extending the weaker axis in single axis, you can always the minor axis is the weaker axis. If you put apart, what happen? The our when we put apart, what happen? Our section is strengthened, and the weaker axis uh, uh, will be the moment of inertia will be as a major axis. That is the main purpose of doing a part. So lacings are the most commonly used lateral system in built-up compression member. Apart from flat bars, other common section, angle section, channel section, tubular section, lacing may be used as a lacing system. So these are the lacing. These lacings may be the flat. This lacing may be the angle section. The lacing may be the channel section. Anyone you can use as per your requirement or issue. Okay, so that is the main purpose that I will say equal to I want 5. That is equal to I want. So such that you have to make the section. So that is the main purpose of the built-up section. It may be the battering system, it may be the lacing system, or it may be the combined system. Now we will see the failure modes of lattice compression member. The lattice compression member or lashing system, it may be buckle or built up members as a whole. The buckling of the whole member, any whole member will buckle or bend. That it may be happen. So that is the first case. It may be the failure of the whole section by buckling. Second, the buckling of the main component. What are the main components in the lashing system? You know that these two columns, they are the main component. They are considered as the main component in the lashing system. In the lashing system, and buckling of the main component, yani only it may happen the buckling of one side of the column may buckle. Okay, so that type of failure will happen. Then third one, the distortion of the section. Distortion of section means due to welding or due to the building or due to the uneven load. What happens there is twisting of the member. You can see in the plant. You can see in the plant that twisting is there. Okay, the twisting of member due to the twisting moment or unbalanced moment, that may happen. That is called as the distortion of the cross section, and that will happen. That is the failure type of the your lashing system or built-up system, you can say. And fourth one is the failure of lashing. Lashing bar we are providing for in the lace column, may the failure of the lashing system will happen. Okay, so generally generally what happens sometimes the lashing system may be the failure of on the lattice lashing what we are providing. So if failure in the lashing, then that failure is called the failure of the lashing. So these four types of failure may be in the lattice compression member. It may be the lashing system. It may be your battery system. So distortion of section you have seen failure of lattice member. This also we are seeing. So this may be happen. Now we'll see the general requirement for the from the IS code, that is clause number 7.6, IS 800 2007, for the lacing column. So compression member comprising of two main components. Two main component means two main bar. It may be eye, it may be channel. Okay, it may be H section component laced and tried should be real practical. तो जहाँ पर हम टाई कर सकते हैं, जनरली वी आर टाइम द इंक्लाइन member, that is called the lacing system. Have a radius of gyration about axis perpendicular to the plane of lacing, not less than the radius of gyration about the axis in parallel plane. यही बात जो मैंने आपको यहाँ पर बताया कि radius of gyration about the two axes that should be same. That is the purpose of we are going for that. So if I will say this is the ZZ axis, major axis, and YY axis. Now this we are taking apart, so that you can say that if RZZ is equal to RYY, this is the main purpose of going for the built-up section, lacing system, and the backbone system. So here, what we will say, the two main component of lace tied should be were practicable, our radius of gyration about the axis perpendicular to the plane of the lacing, perpendicular to the plane of axis y, and not less than the radius of gyration about the axis in the plane of lacing. So both radius of gyration, that major axis and about the minor axis, should be equal, such that we have to place the column of such spacing of the column we will put. That is the clause number 7.6. You can see here in the lace column, member comprising two main components, laced and tied, should be practicable, have a radius of gyration of the axis perpendicular to the plane of lacing, not less than the radius of gyration about the parallel axis parallel to the plane of lacing. Perpendicular and parallel means it's ZZ and the YY axis. Okay, so that is the main purpose of we are providing the lacing system to the column in the or the built-up compression member. तो हम लोग compression member के लिए क्यों जाते हैं, built-up compression member के लिए क्यों जाते हैं, कि हम देखते हैं कि हमारे अगर सिंगल रोल इस सेक्शन के लिए हम जाते हैं तो हमारा एक जो एक्सिस है जनरली माइनर एक्सिस का है वो कमजोर होता है, वो वीक होता है और उधर से बकलिंग के चांसेस ज्यादा होते हैं. तो हम क्या करते हैं, अगर हम दो रोल डिस्टेंस सेक्शन लेंगे तो हम उसको इतनी डिस्टेंस पे दूर रखते हैं कि हमारा जो रेडियस ऑफ गायरेशन है वो RZZ और RYY वो इक्वल रहे. तो इसका मतलब क्या हुआ कि हमारा मोमेंट ऑफ इनर्शिया अबाउट बोथ एक्सिस विल बी सेम, क्योंकि यू नो दैट R इज नथिंग बट अंडर रूट ऑफ I upon A. अगर x z एक्सिस लेंगे तो इट विल बी I z upon A, और अगर y एक्सिस से लेंगे तो इट विल बी I y upon A. Okay, so you have to calculate the radius of gyration about the both axes. You have to calculate the radius of gyration about the both axes such that RZ is equal to RYY. That is the main. Then single lace system on opposite side of the component shall be preferred be in the same direction. What happens if you are going for the lace system? This is the lacing system, you know. This is the lacing system. Inclined members we are providing. Single lacing system is a single. So if you go for the backside also it should be the mirror. It should be in the same direction, that of the shadow of the other, instead of being mutually opposite. तो यहाँ पर opposite दिखा रहा है, तो this system is not good. If you are providing the lacing system, अगर फेस A हम एक तरफ का ले, दूसरा फेस B ले, तो आपको इस तरह लैसिंग सिस्टम उसके शेडो के जैसा प्रोवाइड करता है. जैसे कि हमारे ये आप देखिए कि प्रीफर्ड लैसिंग अरेंजमेंट फॉर सिंगल लैस सिस्टम इज हियर. तो lacing on the face A, lacing on the face B. Face A, because you know in our if you are providing the two column, So if I will say this is the face A, this is the face B. Okay. So if plan it is face A, face B. But if you look from the front side of A, if you look from here, so this one should be same shadow of the face B. Okay. So this type of arrangement is the preferred arrangement. This one is the case of preferred arrangement. आप ऐसा नहीं कर सकते कि एक इस तरफ है और दूसरा उसके उल्टे डायरेक्शन में. You don't do that. Okay. तो एक तो उसका क्या हो जाएगा? That will be in opposite direction. यानी हम उसकी जो स्ट्रेंथ है वो हम वीक कर रहे हैं. ये डबल है, ये इस तरह है. अगर हम इस तरह इधर भी पॉइंट करते हैं तो दैट विल बी ओके. ये जो हमने यहाँ पर देखा. और इसी तरह अब अगर स्टील आईएस कोड में देखेंगे, आईएस कोड में भी आप देखेंगे तो फिगर में आपको देखिए कि अगर लेसिंग फेस ए है तो फेस बी का भी आपका सेम आपका वो रहना, उसका शेडो रहना चाहिए. क्या रहना चाहिए? शेडो या मिरर इमेज आप बोल सकते हैं. मिरर इमेज आप बोल सकते हैं. ओके. तो दैट मिरर इमेज इफ यू सी, so this one is the this one is the preferred and this one is not preferred. So here also in IS code you can see. So if face A view look, it is like this. Face B, it will look opposite of this. Okay. So likewise, it should be the shadow of the face A and face B, and this is the preferred lacing arrangement. This one is the preferred lacing arrangement. Okay. So I will bold some. This one is the preferred lacing arrangement, and this one is not preferred because it is not shadow. It is the shadow of the image. So likewise it is given it is taken from the our Indian Standard Code IS 800 2007. Then you can see that double lacing system and single lacing system on opposite side of the main component shall not be combined with the cross member perpendicular to the longitudinal axis of the strut, unless all forces resulting from the formation of the strut member are calculated and provided for in the lacing and fastening. So double lacing system and single lacing system on opposite sides of the main component shall not be combined with cross members perpendicular to the longitudinal axis of the strut, unless all forces resulting from the formation of strut members are calculated. Okay, so generally we are providing the in two phases. We don't need here. Okay, so that is in single lacing system and double lacing system. The opposite side of main component shall not be combined with the cross member perpendicular to the longitudinal axis. Okay, so these are the cross members. Generally, if they are only if these cross members are there, we are saying it as a battening system. Okay, so combined with the cross member perpendicular to the longitudinal axis of the strut, unless all forces resulting from the formation of the strut member are calculated and provided for in the lacing and the fastening. Okay, now some design specification for the lacing bar. Lacing bar किसको बोलते हैं? This one, the inclined member. These are nothing but the lacing bars. This one nothing but lacing bars. Okay, in double angle also these are nothing but lacing bars. How to avoid this given in the IS code. Okay. So the lacing of compression member shall be proportional to the resist transverse shear. Transverse shear, that is V. What is the transverse shear? You can see in the figure also. This is D. The V is the transverse shear. Okay. So this transverse shear it will resisted by the column. The lacing of the compression member shall be proportional to the resistance of total transverse shear at any point in the length of member equal to what is the transverse shear? 2.5% of the axial force. What is the axial force? Axial force coming on the column. So if you see this column, okay. So this column due to the load P, what happened? The force is going to the lacing system, and this force is F. Okay, so that is F should be uh, that is F should be axial 2.5% of axial force and 2.5% of F in the member, which shear shall be considered as divided equal among all the transversal parallel to the plane. So all the with lashing system, it means that two lashing systems are two faces are there. One face here and another face is here. Okay. तो everywhere it is divided equally among all the transit. तो यहाँ पर अगर सिंगल लेसिंग सिस्टम है तो इक्वल डिवाइड करें तो ये एक हो गया, ये दो हो गया, है ना. तो V is equal to 2.5% of the axial load. Axial load is nothing but our P. Okay, our P. Okay, so that is the total transverse shear force. It is the total transverse shear force, where P is the axial force in the member. P is the axial force in the member. Which member? Main member. Okay, so this is the P is the axial force in the member. For single lashing system, two parallel faces, जैसे मैंने यहाँ बताया आपको, two parallel faces, 1 and 2, two parallel faces are there. Single lashing system में faces for force on each bar. So what will be the value of L? The F, yani force, this force, this force, this force F, this F is equal to V upon transverse shear n times sine of theta. N times sine of theta. If you consider it is a theta, this is the P, okay, and this is the theta, okay. So that figure will be something. This is the. It will be like this. This is the F, okay. This one is this angle. This angle we are and theta. This is the P. Okay, so sin theta is, अगर हमने यहाँ पर देखेंगे तो sin theta is equal to opposite upon adjacent. So this is V upon N. Okay, so opposite is V upon N. On this, so sin theta is V upon N. V upon N upon F. So I will take here, and V upon N sin theta will be the case. Okay, तो यहाँ पर क्या हो जाएगा? If you apply the sin theta, तो sin theta will be V upon N divided by F. I will take another side and sin theta here, so it will be F is equal to V upon V upon 2 sin theta. Why 2? Because in single lashing system, one is A face, another is the opposite face. So that's why the N value is 2. N is the number of transverse system in the parallel plane. तो पैरेलल प्लेन में एक ये हो गया, ये उसके अपोजिट साइड में, यानी ये जो हमारा डबल रोल्ड सेक्शन है, एक ये फेस में आ गया, एक दूसरा फेस में आ गया, तो दिस इज 1 एंड दिस 2. हाउ मेनी आर देयर? द वैल्यू ऑफ N इज 2. बट इफ डबल लैशिंग सिस्टम इज देयर, तो यहाँ पर क्या हो जाएगा? डबल लैशिंग सिस्टम में 1 2 और उसके अपोजिट साइड में, यानी यहाँ पर 2 सिस्टम है तो यहाँ पर 1 2 और फिर 3 and 4. So likewise, if double lashing system is there, so this N value will be the 4. So F is equal to V upon 4 sin of. Okay, so that is the case how you have to find out the force in the lashing system. Force in the lashing system is nothing but F. और our assumption is that कि जितने भी लैशिंग सिस्टम है, 2 है सिंगल लैशिंग सिस्टम में, एक फेस पे है और दूसरे फेस पे है तो 2 हो गया. डबल लैशिंग सिस्टम में एक फेस पे 2 है तो दूसरे फेस पे 2 है तो 4 हो गया. तो N की वैल्यू यहाँ पर सिंगल लैशिंग सिस्टम में 2 है, N की वैल्यू यहाँ पर डबल लैशिंग सिस्टम में 4 है. तो F क्या हो जाएगा? हम क्या कंसीडर करते हैं कि जो वर्टिकल फोर्स है वो हमारा इक्वली डिस्ट्रीब्यूट होगा हर लैशिंग सिस्टम में. That's why we are dividing with the 2 times in single lashing system and 4 times in the double lashing system based on the laced bar, based on the number of laced bar. So here 2 number of laced bars are there for a phase 1, phase A and phase B. Here 2 number of lashing in phase A and 2 lumbar in the face B. That's why 4. Okay, that's why it is 4. So that is the force in the lesson. Force in the lesson we have to find out like this. Okay, now the slenderness ratio LE upon R of the lesson bar should not be. So we are already studied time. You have another class, so we will take the extra classes. अभी किसका लेक्चर है आपका सेकंड हेलो खाली सर का लेक्चर आपका है Shall we continue? I will ask you the खाली सर क्या बोल रहे हैं
सर ये लेक्चर आपका ये फर्स्ट खालिद सर का था
नहीं टाइम टेबल चेंज हुआ ना आप देखेंगे क्या टाइम टेबल चेंज हुआ है हेलो खालिद सर आपका सेकंड लेक्चर है आप लेंगे कि कंटिन्यू करूं मैं थोड़ा लेट हो गया था लेक्चर ठीक है अगर आप बोलेंगे तो मैं कंटिन्यू कर लेता हूँ बच्चे हैं ऑनलाइन मेरे साथ ओके सर थैंक यू तो वी विल कंटिन्यू खालिद सर ने हमको परमिशन दे दिया है ठीक है ना तो वी विल कंटिन्यू आप लोग साथ साथ में जो है वो लिखते चलिए ठीक है तो स्लेंडरनेस रेशो LE by R of the lacing bar should not exceed 145. These are the clauses, huh? So what I am showing here, that is in our high school, these things are already given. You don't have to remember. You can see here. Single lace system on opposite face of the component being laced together shall preferably be in the same direction so that one is the shadow of the other. ये हम लोग ने देखा clause पहले. Now the effective slenderness ratio of the lace column shall be taken as my screen is visible to you. I think so, है ना? Shall be taken as
yes sir
1.05 times pi KL by R0. तो स्लेंडरनेस रेशियो जैसे हम लोग मालूम करते हैं उसका कितना इंक्रीज करना है 5%. 1.05 टाइम्स मीन्स 5% इंक्रीज करना है द एक्चुअल मैक्सिमम स्लेंडरनेस रेशियो से इन ऑर्डर टू अकाउंट फॉर शेयर डिफॉर्मेशन इफेक्ट. इसके लिए शेयर डिफॉर्मेशन इफेक्ट को कंट्रोल करने के लिए हम लोग को क्या करना पड़ेगा 5% हमको स्लेंडरनेस रेशियो इंक्रीज करना है. ओके तो यहाँ पर आप देखिए तो सिंगल लेसिंग सिस्टम में लेंथ बिटवीन इनर बोल्ट ऑन लेसिंग बार LE इज इक्वल टू L. डबल लेसिंग सिस्टम अगर है bolted at ends at intersection, the LE will be 0.7 times over. So this slenderness ratio is generally depend. We know that slenderness ratio lambda is nothing but LE upon R. Okay, and LE is nothing but K into L. Okay, तो फॉर लेसिंग बार है ना, अभी हम लोग पहले जो सिलेंडरनेस रेशियो देखते थे किसका देखते थे, यार फोर कॉलम। यहाँ पर आपका ये जो बात हो रही है किसकी हो रही है, आपका जो ये लेसिंग बार है, ये जो लेसिंग बार है आपका, ये यहाँ से यहाँ ये लेसिंग बार है, इसके ताल्लुक से हो रही है। ये स्मॉल एल आपको दिख रहा है, दिस इज लेंथ ऑफ लेसिंग बार। ओके, तो इसके ताल्लुक से हमारी अभी यहाँ पर बात हो रही है। ओके, तो उसका सिलेंडरनेस रेशियो क्या रहेगा, अगर सिंगल लेसिंग है, बोल्टेड है दोनों एंड में, तो के की वैल्यू क्या रहेगी, के इज इक्वल टू 1। इट मीन्स दैट एल इज इक्वल टू एल। ओके, और इसी तरह अगर डबल लेसिंग सिस्टम है एट एंड, तो के की वैल्यू यहाँ पर क्या है, के की वैल्यू यहाँ पर 0.7 है, इसलिए एल इज इक्वल टू 0.7 एल। ओके, स्मॉल है। ओके, इसी तरह अगर वेल्डिंग है आपके लेसिंग में, एट दैट टाइम ऑल्सो योर इफेक्टिव लेंथ एल इज इक्वल टू 0.07 टाइम्स ऑफ एल। तो समझ में आया लेसिंग बार का इफेक्टिव लेंथ हमको कैसे निकालना है ना, and based on that effective length you have to find out the cylinderness ratio। अब यहाँ पर क्या है, cylinderness ratio Le upon R of the lessing bar should not exceed, तो Le upon R should not be greater than 141। तो यहाँ पर अगर हम लोग लेसिंग बार का आप देखते हैं cylinderness ratio, so it is given in your clause also, you don't have to remember it। So you can see here, this is given clause number 7.6.6.3। Okay, so the slenderness ratio KL by R of the lessing bar shall not exceed 145। Okay, so the slenderness ratio for the lessing bar shall not exceed 145। So this is slenderness ratio of the lessing bar, not the laced column. Okay, that should be remembered in your mind. Okay, so this is the slenderness ratio of your lacing bar, and that lambda of the lacing bar should not be greater than 145 as per the clause number 7.6.6.3 at as per clause number 7.6.6.3। Okay, for flat bars of thickness T and width B, the slenderness ratio will be, the slenderness ratio you can find out from a flashing bar, that is lambda is equal to Le upon R। Le हम लोगों ने ऊपर से मालूम कर रहे हैं, Le is equal to, if bolted is there, L is equal to L। If welded or double lashing system is there, then L is equal to 0.7 times of L। So L हमको मालूम हो गया, and R is nothing but under root of I upon A। So so you know if the flat bar is there, I is equal to PD cubed by 12। Okay, and A is nothing but B into D। So here D is nothing but your thickness. We are taking T, small t. So that's why you can see तो I upon A is equal to BT cube by 12 and divided by BT. तो यहाँ पर LE upon root 12 upon T is the slenderness ratio for the lacing system. And this value should be less than 145 as given in clause number 7.6.6.3, that clause 7.6.6.3 for slenderness ratio limiting value of the lacing bar. Now width of lacing bar. So in riveted bolted connection, the minimum width of lacing bar should be more than 3 times the nominal diameter of the end connection, end connector. तो यहाँ पर क्या दे रहे हैं? This width of lacing bar, you see, the width of lacing bar should be of lacing bar width of lacing bar 7.6.2 दिखा आपको? तो ये क्लॉज है आपका पेज नंबर 50 पर. In bolted or riveted connection construction, the minimum width of lacing bar shall be 3 times the nominal diameter of bolt. तो यहाँ पर अगर हम बोलेंगे तो width of lacing bar it should be greater than, I will say width of lacing bar should be greater than 3 times of diameter of bolt, 3 times of. So what is the width of lacing bar? This is the lacing bar, inclined lacing bar, and this is, it is nothing but your width of the lacing bar. I am just for explanation purpose I am denoting it. Okay, so this is the width of lacing bar. This is the length. This is the length of lacing. Okay, so width of lacing bar should not be less than how much? 3 times of nominal diameter of the bolt or rivet, whatever you are. Okay. Now thickness of lacing bar. Thickness of lacing bar. The thickness of lacing bar, the minimum thickness of lacing flat bar should be as follows. T is greater than L by 40 for single lacing system. Single lacing system. यानी फ्लैट बार अगर है, this is your flat bar, you are providing as a lacing system. So this is nothing but the thickness. This is the thickness T. So this T value should be greater than L by 40. L क्या है? Length of lacing bar. L by 40 for single lacing system. Similarly, T should be greater than L by 60 for double lacing system. This is clause for 7.6.3 for the thickness of lacing bar. यहाँ पर दिया हुआ है, in words it is given, the thickness of flat lacing bar shall not be less than 1/48, and 1 by 40 of its effective length for single lacing system, and 1 by 68 of the effective length for double lacing system. So here effective length is given. You can write, and this T should be greater than LE by 40, or T should be greater than LE by 60 in case of double lacing system. In case of single lacing system, it is LE by 40. So where L is the length between the inner bolt, end bolt or welds. So inner bolt means this is the lacing bar we are providing to the column, our column. Okay, if 2 bolts are there, so this distance, inner distance bolt is nothing but 1. Okay, not heavy. That is not heavy. Okay, so that you have to remember. These are the clauses, and you will see when we go for the example, you can understand this. Now, angle of inclination The lacing bar, the lacing bar, whether in double or single system, shall be inclined at an angle not less than 40 degrees and not more than 70 degrees. So what is the angle of inclination in lacing system? The angle of inclination is in between 40 degree to 70 degree. The angle of inclination, if I will say theta, it should not be, it should not be less than, should not be less than 40 degree. Then it means that it should be greater than 40 degree and it should not be greater than 70 degree. This is the angle of inclination. Other form में भी हम लिख सकते हैं theta is should be greater than 40 degree, should be less than 70. इस तरह भी हम लिख सकते हैं, है ना? तो इंफेसिस करने के लिए यहाँ पर should not be less than, should not be greater than का वर्ड हम लोग यूज करते हैं for better understanding. Okay. Now spacing. The maximum spacing of lacing bar should be such that minimum slenderness ratio will be. The maximum spacing of lacing bar should be such that minimum slenderness ratio shall be L by R minimum. C for the lacing bar, it should be 0.7 times of lambda max. Lambda is slenderness ratio, what you are calculated for the lacing bar. Okay, or 50 or 50. तो इस दोनों में से ये दो वैल्यू में 0.7 times of lambda or 50, whichever is minimum is nothing but the spacing of the lacing bar we have to consider. And while designing you will see you can calculate that, and you will understand the L by R minimum value should not be uh, 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 should be equal to, or you can say 0.7 times of lambda max or 50, whichever is minimum. Where lambda max is the maximum slenderness ratio of compression member as a whole. Where lambda max is the slenderness ratio, that is lambda 0, we are calculated KL by R 0 calculated above. इससे that is the lambda max value. That is the lambda max value. Okay? That is the lambda. Okay. Here is the distance between center of connection of the lattice bar. So this is the N. So the east side is different. This one is the N, and it is also sometimes it is denoted by A, sometimes okay. So it is denoted by A. It depends on you what you can denote. Okay, but you should know the how to calculate. Then R minimum is the minimum radius of gyration of component of compression member. So R is the RC minimum is the radius of gyration of the component member. Okay. Now the attachment of the two member. The riveting, bolting or welding of the lacing bar to main member. No, lacing bar of the secondary member. Main member are two road history section we are joining, and this is the your lacing bar. So this is this one they are called as the main member. What the riveting, bolting or welding of the lacing bar to the main member should be sufficient to transmit the load in the bar. Okay, so because we are transferring the load through this main bars to the this force F to the lacing system. Okay, तो इस तरह उसका कनेक्शन रहना चाहिए कि आपका लोड इक्वली डिस्ट्रीब्यूट हो हर लेसिंग बार में. वेल्डेड कनेक्शन है, where welded lacing bars overlap the main members, the amount of lap measured along either edge of the lacing bar shall not be less than 4 times the thickness of bar of the member. So the welded connection, the overlap should not be less than 4 times of your thickness of the lacing bar very 40, whichever thickness of the 4 times of the thickness of the bar or the member width, whichever is whichever is less. Welding should be sufficient to transmit the load in the bar and shall in no any case be provided along each side of bar for the full length of lag. तो वेल्डिंग आप जब करते हैं तो वेल्डिंग शुड बी सच दैट it should be provided both side, each side of the bar for the full length of leg. Whatever leg we require, that should be that part of welding should be provided properly. Where lacing bars are fitted between the main members, they shall be connected to each member by fillet welds on each side of the bar or full penetration butt welds. The lacing bar shall be so placed as to generally opposite the flange or sub of stiffening element of the main member. So that is, you can see the force and here required. In bolted connection, the number of bolts N is equal to F upon R, force upon R, R is the bolt value. Bolt value, we are already learned in the unit number 1. Bolt value is the minimum of shearing strength and bearing strength. है ना? Minimum of shearing strength of bolt or bearing strength of bolt is nothing but bolt value. Okay? So 2F cos theta upon R, 2 then the F is equal to force in the lacing bar and theta is the angle of inclination. Now we will see the design of lacing system. You see the design of lacing system. Some steps are there. We see the steps for design of lacing. तो पहला स्टेप ये लैसिंग सिस्टम में क्या रहता है हमारा लैसिंग सिस्टम में हमारे कंपोनेंट क्या है लोग ने बार बार देखे आई विल गो वापस से हम ये लैसिंग सिस्टम है आपका तो लैसिंग सिस्टम आप देखेंगे तो ये मेन कंपोनेंट एक तो ये आपका कॉलम है ओके इस कॉलम ये आर द मेन कंपोनेंट एंड सी दिस इज द लैसिंग बार अब देखिए कि लैसिंग बार आप इधर से देख रहे हैं तो इसके अपोजिट डायरेक्शन में सेम उसका शेडो है पीछे के डायरेक्शन दैट इज द मेन कंपोनेंट तो दिस इज दिस टू कॉलम्स रोल्ड स्टील कॉलम दे आर द मेन कंपोनेंट्स एंड दिस आर ईच मेंबर ओके ये है हमारा नाउ डिजाइन स्टेप्स इन द लैचिंग तो दिस स्टेप्स अगर ये स्टेप आपको मालूम है वी कैन सॉल्व द एग्जांपल वी विल गो थ्रू द स्टेप एंड वी विल स्टार्ट द एग्जांपल टुमारो चूज द लैसिंग सिस्टम दैट इज आइदर सिंगल लैसिंग सिस्टम और डबल लैसिंग सिस्टम चूज द एंगल ऑफ इंक्लिनेशन थीटा विद एक्सिस ऑफ कंप्रेशन मेंबर ओके तो ये हमारा लैसिंग सिस्टम है आप सिंगल लैसिंग सिस्टम के लिए जाइए या आप डबल लैसिंग सिस्टम के लिए जाइए कोई भी सिस्टम के लिए आप जाइए आपको डिसाइड करना है क्या क्या सिंगल लैसिंग सिस्टम है कि डबल लैसिंग सिस्टम है एंगल ऑफ इंक्लिनेशन मीन्स दिस आवर लोड तो दिस कम हियर तो दिस एंगल इज नथिंग बट थीटा एंगल ऑफ इंक्लिनेशन choose the angle of inclination theta axis of and this theta value should not be greater than 70 degree and should not be less than 40 degree is given. For given shape find out the gauge distance G on each side and find the distance A between the bolt center then compute the spacing. यहाँ पर गेज डिस्टेंस क्या है गेज डिस्टेंस इज जी गेज डिस्टेंस किसको बोलते हैं बोल्ट्स के सेंटर से मेंबर के एंड तक का डिस्टेंस है दिस इज कॉल्ड एज गेज डिस्टेंस ओके ओके तो दिस इज कॉल्ड एज गेज डिस्टेंस ओके Thus according to the figure you can find out that. And L is equal to, इसको sometimes हम लोग क्या डिनोट करते हैं, A. ओके, हियर यहाँ पर A ये दिया स्पेसिंग, टोटल स्पेसिंग दिया है और यहाँ पर A दिया, तो आई विल इरेज दिस, नो इश्यू, विल कंसीडर. So L is equal to 2A time theta. L is equal to this, L is equal to 2A time theta. You know that this is the theta, है ना. अगर मैं यहाँ पर फिगर बनाता हूँ तो दिस वन इज, this is L by 2, this is theta, okay, and this is A, okay. तो tan theta means opposite upon addition. Tan theta अगर मैं लिखता हूँ तो tan theta is equal to, opposite is A, addition is L by 2, okay. तो L is equal to, अगर मैं L इधर लेकर आ गया, this 2 will be up, L is equal to 2A upon tan theta. L is trigonometry, okay, and small l is equal to A upon sin theta. Small l for single or double relation system, small l is nothing but A upon, okay, and A is nothing but, A is nothing but 2 times G into S. S is the spacing of your main member, spacing of main member, spacing of main member. This is, and that we have to find out. All this from the trigonometric equation you can find out, and then the spacing you can calculate. We will see this while calculating. Then find the slenderness ratio of each component of and check the slenderness ratio. हाँ, अब हमको क्या मालूम करना है, slenderness ratio each component lessing bar का, okay, that we have to find out. And this slenderness ratio, you know that L by R minimum, it may be lambda max, and lambda is equal to L upon R minimum, okay. R minimum जो है L हम लोग ने कैलकुलेट किया, R minimum can calculate, and that is nothing but what is it, L upon root 12 upon, we have formula already divided here, lambda here, L root 12 upon T, L root 12 upon T. From this you can find out what is the design of lesson system, what is the design of this system. So here this is nothing but 5, you can calculate. You will find the length of each lesson between the inner and board, and then find the effective length. So you can find out the L inner end of the edge, that is the distance L. डबल लेसिंग सिस्टम के लिए 0.7 L, वेल्डेड के लिए 0.7 L, और अगर सिंगल लेसिंग में बोल्टेड है तो दैट वैल्यू AD is equal to A. You can find out the based on the length, you can find out the effective length. Then select the thickness of lashing consists of flat. So T should, based on this, T should be greater than L by 12. Single lashing system, make L by 40. By single lashing system, the double lashing system, the T should be greater than L by 60. Then lambda lashing, L upon root 12 upon T, as we have discussed. This lambda is different. Each component of the lambda of the main column and lambda of the each component we are applying. Then calculate the compressive strength. Compressive strength of the member, the main member. Calculate this and main member supporting member and lashing. Compressive strain in lashing also you find out. If I will say it is a compressive force, one lashing bar, then V is equal to 0.25, that is 2.5% of the P. If you write in point 22.5 divided by 100, it means that 0.025. Okay, so that's why here it is written 0.025. That is the force in each lesson. Compute the developed compressive strain and tensile strain in the lashing bar. It should be less than the permissible compressive strain or tensile stresses. So अब यहाँ पर हमको compressive stress and tensile stress in lashing should be less than the permissible compressive, nothing but V for the point. The transfer shear that is equal to 0.5% of P. इससे हमको मालूम पड़ जाएगा टेलर कंप्रेशन जो भी है. Select bolt diameter यानी the D where you can find out, and from this minimum width of lashing bar it should be greater than 3 times of D. अगर ये 20 आपने कंसिडर किया तो B 3 into 20 it should be greater than 60 mm thickness of the. समझ में आया? Likewise, the number of bolt required can be found. Number of bolt required can be found n upon f by r. This is the force in lashing bar, and this is the bolt value. It is the minimum shearing strength or bearing strength of the bolt. Then design end connection for lashing system. Then you have to design end connection for lashing system. Check if the number of bolts are sufficient to withstand the loading member. तो हम नंबर ऑफ बोल्ट निकाले, लेकिन नंबर ऑफ बोल्ट आपके उसमें बैठना चाहिए, और दूसरी बात it should be sufficient of taking that much of load. Okay, this one is the explanation how to design uh, using the programming. Okay, so select the angle. Okay, the 4 angle section is the given two lashing bars back to back, face to face lashing system. So these are different types of double lashing system of the programming, and you may also do such type of programming uh, if possible. If you know the programming languages, many programming languages are available: C, C++, Java, Oracle, and VB. Combining you can do. So you can make, if you know the software, you can make this. You can input the data, and you can get the results. Okay. So all the calculation it will be done by the what program you will made in software. So if you know the how to calculate the each and every step of the lashing system, so you can do the programming in Excel also. Okay, in Excel also, there is a spreadsheet in VB, Visual Basic, in basic language, in C language, and many now many other another languages are coming into the picture. By using that languages, computer programming languages, you can design a computer program, and you can design a lesson system easily by multiple of options. Okay. Now we see the one example, and that example we will take in next class. Now I will repeat the steps for design of the lesson system once again, so that you can able to find out. Okay. तो सबसे पहले क्या करना है, हम स्टेप बाय स्टेप प्रोसीजर देखेंगे ताकि आपको आगे के लिए you can able to understand it and you can able to design. So, built-up compression member हमने शुरू किया था, that you know how many types of built-up compression member you can go for, maybe single eye, double channel, 4 angle, okay, sections. You can use for built-up sections, column, one compression member. This is the angle of inclination, flexing system. Later we are taking the 45-degree. It depends on you. Now step for design of base column. Step number 1, assume the design compressive stress FCD. FCD किसको बोलते हैं हम लोग? हाँ, compressive. And FCD for the column, you know, we already earlier it should be in between 120 to 180 MPa. इसके बीच में सिलेक्ट करते हैं. यहाँ पर लैसिंग सिस्टम है, तो यहाँ पर 125 MPa से 175 MPa के बीच में ट्रायल सेक्शन हम लोग ने. नाउ फ्रॉम द ट्रायल सेक्शन यू हैव टू कैलकुलेट, जैसे कॉलम हमने डिजाइन किया वैसे फ्रॉम द this assumed FCD, you can find out the area required for the column. So put the PU, value of load upon FCD assumed, you will get the area required. Then select the suitable channel, say 2 channel section, 2 IS section or 4 angle section for built up column, and then find out the area provided. Area provided should be greater than area required. अगर ये है तो you will go further. Then for design of built up section, the section are so placed that your RZZ, RYY is equal to RZZ, or you can say IZZ is equal to IYY. IZZ is equal to IYY. नीचे नीचे क्या काउंटर? वो ऊपर बताया ये फिर आगे बढ़िए सेक्शन. The calculate the effective length L is equal to K into L. So calculate effective length K into L. K is the factor, है ना? And from where we will see this is from table number 11 of IS code. तो IS code में table number 11 में पेज नंबर 45 पर ये दिया हुआ है. तो यहाँ से इफेक्टिव लेंथ हम ले लेंगे. कॉलम है ना, कॉलम के लिए इफेक्टिव लेंथ, अगर एक एंड फ्री है दूसरा फिक्स है 2L, एक एंड हिंज है दूसरा रोलर सपोर्ट है, देन आल्सो 2L. वैल्यू ऑफ K is 2, बोथ साइड हिंज कंडीशन है. वैल्यू इज K वैल्यू इज 1, one side fixed, one side roller. So value is K value is 1.2, one side hinge, one side fixed. K value is 0.8. If both ones are fixed, then K value is 0.65. So likewise, we have to find out the effective length. Then effective length is effective slenderness ratio you have to find out. You know that slenderness ratio is nothing but lambda is equal to LE upon R minimum, है ना. अभी यहाँ पर अब हमारा जो R minimum है, हम लोग ने क्या किया यहाँ पर ऑलरेडी RYY should be approximately equal to RZZ. अब इसमें जो भी मिनिमम आएगा RZZ मिनिमम है तो वे यहाँ पर R minimum जगह पुट करेंगे. You can find out the lambda value, that is slenderness ratio. लेकिन यहाँ पर क्या बोल रहा है, शियर डिफॉर्मेशन इफेक्ट को अकाउंट करने के लिए हम लैम्बडा की वैल्यू इंक्रीज करते हैं. इसको बोलते हैं इफेक्टिव स्लेंडरनेस रेशियो. लैम्बडा इज इक्वल टू 1.05 टाइम्स, यानी 5% मोर देन द लैम्बडा. ओके, फॉर K L by L and Fy is the buckling class. Fy टेबल से भी हम मालूम कर सकते हैं this lambda value. If you know the value of LE and R minimum, Fy or buckling class, you can find out the. And the buckling class is 9C for any built-up section. Built-up section के लिए अगर हम buckling class देखें, IS code में टेबल नंबर 10 में दिया हुआ buckling classification of section. देखिए buckling classification of cross section IS 800/2007 में ये दिया हुआ है. IS single I section, built-up section, Okay, welded box section, hollow section, channel angle T, solid bar. इसी तरह बिल्टअप मेंबर अगर है, देखिए बिल्टअप मेंबर लास्ट में दिया हुआ है, कोई भी एक्सिस से उसका जो बकलिंग क्लास क्या रहता है, सी क्लास. Okay, C class है तो table 9C we can use and you can find out. Now you know the PD is equal to AE into FCD और AE into FCD कब रहेगा? FCD AE is nothing but you can see say the AG. What is the cross section area of your two sections and find out the PD. If PD value is greater than PU then trial 1 is okay. ओके, अगर आपकी पीडी की वैल्यू ग्रेटर है पीयू से और अगर पीडी की वैल्यू आपकी लेस आ गई पीयू से, यानी जो एक्चुअल लोड है आपका, एक्चुअल फैक्टर लोड है, दैट इज ग्रेटर देन डिजाइन लोड, तो आपको दूसरा सेक्शन चूज करना पड़ेगा. यहाँ स्टेप नंबर 7 से आपको वापस जंप करेगा स्टेप नंबर 2 पर या 3 पर. ओके, तो अगेन यू हैव टू रिवाइज द सेक्शन एंड चूज अनदर सेक्शन. नाउ अब हमको स्पेसिंग मालूम करना है, स्पेसिंग मालूम करना है यानी एस वैल्यू, कितने डिस्टेंस अपार्ट हमको एंगल चैनल ये सेक्शन रखना है, तो एस की वैल्यू हमको मालूम करना पड़ेगा. तो उसके लिए हम क्या करेंगे, हम लोग ने क्या, हमारा मेन अजम्पशन क्या है कि आर जेड जेड इज इक्वल टू आर वाई वाई. ये कब रहेगा, क्योंकि आर इज इक्वल टू आई अपॉन ए, तो ये तो चेंज नहीं होता आई की वैल्यू. तो इफ यू इक्वेट आई आई जेड जेड इज इक्वल टू आई वाई वाई, हम इसको इक्वेट करेंगे तो यू नो दैट तो पैरेलल एक्सिस थ्योरम वाई वाई एक्सिस पे डिपेंड करना पड़ेगा, क्योंकि जो वाई वाई एक्सिस का वाई वाई जो आपका होल मेंबर का जो एक्सिस है ये कहीं और है, और जो दो मेंबर आप यूज कर रहे हैं उसका वाई वाई एक्सिस कहीं और है. So that's why this is the S. S is the spacing between the two channels. It may be facing each other. It may be. तो यहाँ पर पैरेलल एक्सिस थ्योरम अगर हम लोग लगाते हैं आई वाई वाई को, तो इट इज नथिंग बट आई जी वाई वाई प्लस एरिया इंटू एच स्क्वायर. एच यहाँ पर क्या है, दिस इज, अगर ये हमारा एक्सिस है तो ये एस बाय 2 plus this value is CYY and whole square. So you can find out the value of S by using this parallel axis theorem. About y-axis, we will get IZZ is equal to IYY, and by utilizing you can find out the value of spacing S, because CYY you can take from the table, steel table. CYY value you can take from the steel table. Now you have to assume the angle of inclination. Generally we are going for the 45 degrees. It is in between the 40 to 70 degree. तो आप 50 डिग्री भी ले सकते हैं, 60 भी ले सकते हैं, but it should not be greater than 70 degree or it should not be less than 40 degree. Okay, so that's why you are going for this. Now step number 8, you have to find out the maximum spacing in lacing bar, that A1 or should be such that the minimum cylinder ratio of the component member A1 upon Ry is not more than 140, greater than 50 to prevent the local buckling, or 0.7 times of cylinder ratio as a whole. So A1 upon Ry, it should be less than 50 or it should be less than, ये दोनों में से जो वैल्यू मिनिमम रहेगी दैट वी विल कंसीडर. Minimum is 2. Then design of lacing bar. Now we know the length, we know the A, all this value we know. So design of lacing bar, maximum shear force Vt is 2.5% of Pu, Vt by 2. The compressive force Vc upon N, it is equal to 2. Cf is around. The width of lacing flat should be, you decide with the nominal diameter of the bolt. Then minimum thickness of lacing bar as per the clause 1 by 40 if the member single lacing system. If double lacing system is there, we are going for the 1 by 60 the length of the flat bar between the end bolts or the weld. Then you have to find the radius of gyration for the lacing flat, that is T upon root 2. Slenderness upon R minimum. R minimum already you have calculated here. T upon root 2. Put that value, it should not be greater than 145. All these clause already we have seen. Find out the FCD for the lacing bar from table number 9C. Check PDR. If this value is greater than the compressive force Vt upon N, then we will say that our design is safe. Okay? Then step number 12, you have to design the connection between the main column and the lacing bar. Okay? These are the steps for design of your uh, lacing column, base column, and we will see the example tomorrow. If you have any doubt, you can ask with me. Otherwise, we will stop here. कोई डाउट है आपको? हेलो,
Hello.
कोई डाउट है सर? हाँ बोलिए।
Yes,
No,
sir.
no, sir.
हाँ सर बोलिए देवरे। कोई डाउट है आपको बेटा?
No, sir.
ओके।
सर प्रॉब्लम कर लेने का।
हाँ प्रॉब्लम कल नेक्स्ट लेक्चर जब भी हमारा रहेगा।
ओके ओके सर।
प्रॉब्लम के लिए कैलकुलेटर पेन और पेपर आप लेकर बैठिए, साथ में मेरे आप कैलकुलेट करते जाइए। हमको थोड़ा टाइम लगेगा लेकिन हम प्रॉब्लम सॉल्व करेंगे। अगर एक लेक्चर लगे या 2 लेक्चर लगे विल कंप्लीट। अगर एडिशनल कोई एक्स्ट्रा लेक्चर लगा तो वो भी हम लेंगे। डोंट वरी अबाउट दैट। ओके।